Hey everyone, and a huge welcome back to all of our focused learners tuning in to CloudBridge Tech Labs. I am absolutely thrilled to have you here for Session 9 of Phase 1. So today's explainer is really your critical guide to uncovering the invisible plumbing of the internet. We're going to look at exactly how computers actually communicate with one another just beneath the surface. I mean, if you've ever wondered how your server knows the difference between, say, a secure web request and a database query, or why a streaming video might drop a frame, but a file download literally never loses a single byte, well, you're definitely in the right place. We are decoding the matrix today, and we're focusing strictly on the nuts and bolts of network protocols and ports.
All right, here's our quick roadmap for today. First, we'll hit TCP versus UDP. Second, understanding network ports. Third, DevOps troubleshooting in action. And finally, your Phase 1 mission.
Let's kick things off with Section 1, TCP versus UDP.
Okay, so I want you to think of these two protocols as the primary couriers of the internet. Whenever data leaves your machine or arrives at your server, it's pretty much utilizing one of these two to make the journey. They determine exactly how our data travels across networks, but they take incredibly different approaches to getting the job done. So TCP, it operates just like a phone call. When you make a call, a connection gets established, right? You say, hey, did you receive this message? And the other person says, yes, I got it. It guarantees delivery with an acknowledgement. It is meticulous. Now, UDP, on the other hand, operates way more like a radio broadcast. The radio station doesn't know if you're actually listening. It just blasts the message out once as fast as humanly possible. There's absolutely no guarantee you heard it, but the raw speed, totally unmatched.
And it's exactly this trade-off that dictates when we use each courier. For HTTP, HTTPS, and SSH, you really cannot afford to lose a single letter of a password or line of code. Reliable communication is strictly required there. But for things like video streaming, gaming, and DNS, raw speed is infinitely more important than guaranteed delivery. Think about it. If you're playing a super fast-paced multiplayer game or streaming a live broadcast, and you happen to drop a single frame of video, you definitely don't want the whole stream to just pause and wait for it to arrive. You just want the next frame immediately, right? So let's do a really quick mental check based on what we just established. Which protocol is faster, and which one is more reliable? Think back to those analogies for a second. The radio broadcast is definitely faster, so that's our UDP. There's no waiting around for a hello, yes I hear you response. But the phone call is way more reliable, making TCP the winner for guaranteeing that your data arrives safely and in the exact right order. So UDP wins on speed, TCP wins on reliability.
Moving right along to Section 2, understanding network ports.
So we know how the data travels across the network using TCP or UDP, but how does it know exactly which application to interact with once it finally gets to the server? Well, a network port is an identifier used to direct network traffic to specific applications on a server. Think of your server as this massive apartment building. The IP address gets the data to the correct street address, the building itself, but the network port? That's the specific apartment door number. Without the port number, your data is literally just standing awkwardly in the lobby with nowhere to go. Ports act as these specific virtual doors that route the incoming traffic to the exact right place.
Now, as CloudBridge Tech Lab students stepping into the DevOps world, you really need to practically memorize these crucial common ports. I mean, this is your daily bread and butter. If data comes knocking on port 22, it's looking for SSH to establish a secure shell. Port 80 is your standard, unencrypted HTTP web traffic, while port 443 is your secure HTTPS traffic. Now, for databases, 3306 is the standard door for MySQL, and 5432 is for Postgres. And finally, port 8080 is very commonly used for app servers. Knowing exactly which port belongs to which service is just absolute foundational knowledge for you.
All right, let's dive into Section 3, DevOps troubleshooting in action. You know, it's one thing to just memorize port numbers, but it's an entirely different thing to use that knowledge to handle a blazing fire in a live production environment. So here is your scenario. The application is running, but it is completely inaccessible. You've checked the server and the processes look absolutely fine. The memory is good, the CPU is calm. From the server's perspective, the app is totally alive and kicking. But your user traffic is just hitting a massive brick wall. The outside world cannot connect at all. So what is your very first move?
Well, here are the ultimate command line tools you are going to use to solve this exact problem. You log into that server and you type either netstat -tolnp or ss -tolnp. What do these commands actually do? They check the open ports. They allow you to quickly verify if your application is actually listening on the correct virtual door. Your app might be running perfectly, but hey, if it accidentally bound itself to port 8081 instead of 8080, all that traffic looking for port 8080 is just going to be completely ignored. These commands lift the hood and show you exactly who is listening and where.
And that brings us to Section 4, your Phase 1 mission. For all of you enrolled in CloudBridge Tech Labs right now, we're at a really critical checkpoint. We've laid out the theory, we've given you the commands, and now it is time for you to actually execute. Please review your mandatory Session 9 practice tasks. Task 1, you need to log into your lab environments and check open ports using those exact commands we just discussed. Task 2, you must be able to identify the services running on those ports based on the common ports list. Task 3, you need to demonstrate a solid understanding of when a service is using TCP versus UDP. You absolutely must complete these mandatory session tasks to successfully graduate from this current stage and move on to the next phase of learning.
I want to leave you with this final, provocative troubleshooting thought to keep in your back pocket. Are you sure your app is listening on the right port? Next time an application goes completely dark, don't panic. Just check the doors. Run your commands, check your TCP and UDP bindings, and just trust your foundational knowledge. Remember to complete your mandatory Session 9 tasks so we can see you in the next phase. If you found this explainer helpful for your CloudBridge journey, please take a second to hit that like button and subscribe to the CloudBridge Tech Labs channel so you never miss a session. Get into those labs, start checking those ports, and I'll see you in the next explainer.